Hello everyone. Good afternoon, good evening, good morning, wherever y'all are watching this from. So today we're going to be solving the problem find resultant array after removing anagrams. This is an easy question, but if you're a beginner, it would require a little bit of thinking to optimize the solution. So let's just get ahead with it. You are given a zero indexed string array words where words at I consists of lowercase English letters. In one operation, select any index I such that it lies in the given array, and the previous element and the current element are anagrams. Delete the current element from words. Basically, it's asking you to delete the anagram and only save the first letter, and both of them should be consecutive. Return words after performing all operations. It can be shown that selecting the indices for each operation in any arbitrary order will lead to same result. An anagram is a word or a phrase formed by rearranging the letters of a different word or phrase using all original letters exactly once. For example, DACB is an anagram of ABCD. So let's move ahead with the example. Basically, what they're asking you to do is that if you have this, you pick this, you check behind. If it is an anagram, you remove this. You pick this. If this is an anagram, you remove this. You check this. If this is an anagram, you keep this. Since it is not an anagram, you keep this. Then you check ahead, check behind, go ahead, check behind. If it is an anagram, you remove this, and in the end, you return this. Right? So when I solved this problem, the first thing that came to my mind basically was that I need to remove elements, right? I need to essentially remove the anagrams, the repetitive anagrams. I need to remove all of this, right? So I thought, why not create a list wherein I pick something, I check the next. If the next is an anagram, I remove the next. Listen carefully. I pick something, I pick an element, I check next element, I check next element. If it is an anagram, I remove. If it is an anagram, I remove. If it is not an anagram, I let it stay. Right? This was the first thing that came to my mind, and I'm pretty sure it would come to your mind as well. If you're a beginner, the first thing that comes to your mind is this only, or at least that came to my mind. It all depends person to person, right? So basically we need to do something like this. So let's just assume that this is a list of strings, and then I would pick this, check the next one, right? I would keep on checking the next indexes from that, right? So basically now we need to devise something which keeps a track. So the basic, very brute force approach here, I think, would be to... Oh, and how do we check for anagrams, by the way? The first thing that comes to a beginner's mind is to sort the given strings, right? We sort the given strings, right? This sorted would be AABB, and this sorted would also be AABB. If the sorted strings are equal, then we say that it is an anagram, right? So okay, so we need to pick something, and then we need to check the subsequent ones. Okay, so let's just define our I as 0, and let's just have our n as words.size. ठीक है. Now while I is in range, we need to pick something first. Words.get I. We pick this. We have a temporary variable which saves this, and we sort it. Sort the S. Why is this temporary variable here? I'll come to that in a second. Just keep this in mind. Now, let's assume I pick. What was our next step? Our next step was to check the next element. While I plus 1 is less than n, basically it is in bounds, and our sorted string at I plus 1, basically words dot get I plus 1 should be equal to S, right? Let me just take all of this here. Basically this, right? So what does this do? It checks for bounds. What does this do? It sorts the next word. See, we check the next element, it sorts the next word and checks if it is equal to the sorted string S, right? So if this is true, if that is true, what do we do? We just words dot remove get element at I, right? Words dot remove get element at I, and we update our n. Words dot size. Now you may ask, why Josh? Why are you doing this? Then we increment the I, and then we again update our n. Words dot size. ठीक है, and then we return our words. Josh, I have several questions now. What did you just do? Why? How is this brute force? This is so complicated. So, when you think about it, I am essentially doing the exact same thing, right? I am doing the exact same thing. I am picking the element. Then I am checking for the next one, whether the next is an anagram. If the next is an anagram of the picked one, then we remove it, and then we increase, and then we update our n. Why are we updating our n? Because we are assuming that this is a list. Right? We're assuming that this is a list. So basically we need to update our n every time, because then previously our n was 1, 2, 3, 4, 5. Then we remove this, then our n became 4, right? So we need to update it from time to time. Now I plus plus. Now why are we not incrementing our I inside of this to check the subsequent elements? Because I plus 1, when I remove this automatically becomes the next element, and so it would loop back again here. When the inner while loop loops back, it would again check this, because this was removed, right? So it would check this. What is this temp for, Josh? I don't know, it was just there, it existed. Yeah, so I think that's it. That is our code. So if you dry run this, it picks this. My I was 0. Basically my I was first 0. Then it checked for I plus 1. Was it an anagram? Yes. It sorted and checked. Was it an anagram? Yes, it was an anagram. It removed, my n became 4. First my n was 5, now my n became 4. Now is my I plus 1? Again, my I is still 0. I have not incremented my I. My I is 0. I plus 1. 1. 1 is less than 4. Yes. Is at index 1. Is words at index 1 an anagram? Sorting and checking. Yes, it is. We remove this. We update our I. We update our I to 3. Now again, is this an anagram? No, it is not an anagram. It is not an anagram, so it will not execute this. It will not execute this. It will go straight down. My I became 1. My n became 3. N was still 3. Now we check. Now I plus 1 is 2. Now we picked this, right? This was our picked. We picked this because this plus indicates that we are changing the pick because we are looping back again, right? So we pick this I plus 1. What was I plus 1? 2. Is it greater than 3? Yes. Is 2 less than 3? Yes. So this condition check is the next one, is at index 2, sorted and is an anagram, sorted and checking. Yes, it is an anagram, so we remove this. Our n words dot size became 2. Now I plus 1 is less than n. Both are 2, right? So it is not I plus plus. It does I plus plus. N is equal to words dot size. Again, size was 2. It goes up. I plus plus. I became 2. N was again 2. This loop condition failed. I went outside and I returned this. That was my answer. Now if you see that we're essentially looping through each element once, so that would give me an O of n, right? Then inside we are using words dot remove. This is a very expensive operation because that also costs me O of n. So I have O of n, and never forget, we are sorting. So that would give me an additional m log m, where m is the length of the string. So this is a very big time complexity. The interviewer will not like this, but just for our thought process, how the brute force solution would work, we picked an element, we checked the next element, we removed if anagram, we let it stay if it was not an anagram. Now what were the flaws in our code? Firstly, the biggest flaw was this. Right? Our biggest flaw was this. We're using it unnecessarily, right? Our biggest flaw was this. Okay, so we need to optimize this. We need to remove the remove part. Second, we're using sorting to check for anagrams. Basically, we're checking anagrams in m log m time. Can we optimize that? Can we do that? Yes, we can. So basically, we can improve this completely. We can remove this n, cost by remove, totally, and we can improve this from m log m to just m. How do we do that? Basically, how your thought process should work is that I am taking a lot of time removing stuff, right? Why not just keep on adding? We're removing the unnecessary ones, right? We're removing the unnecessary elements. But instead of removing the unnecessary elements, why can't we just add necessary elements? This would cost me O of n, this would cost me O of 1. Why are we not doing this? Why did this not come into our mind? Because we're still learning. When I solved this question, this did not come to my mind, so it is okay if it did not come to your mind too. So we should add necessary elements. Okay, now we optimize the O of n to O of 1. Now what we need to optimize m log m to m. Basically we need to optimize our is anagram function. We never had this function essentially, but by sorting and checking equal, we were just doing the is anagram function. So basically we need to sort this. We need to optimize checking our anagrams. How do we do that? So basically we create an array of length 26 where each symbolizes A, B, C, D, E, F, G, H, I, J, Z. It is given in the question, all is lowercase, right? So we create an array of length 26, and then let's say we have a string S, A, B, B, A, and string T, B, B, A, A, right? Now what do we do? We iterate through them. First at point 0. For string S we would add, for string T we would subtract. So we added 1 because we found 1A. We subtracted 1 because we found a B. We found a B at both. So at S we added 1, at T we again subtracted 1, at S, so that was when our I was 1. Now I is 2, we are here, so we added, basically we added, it was -1, we added when we got a B, and we subtracted when we got a A. Again we came here, I is 3, we added when we got an A, we subtracted when we got a B. Now after doing this, we again check if all the counts in the character array are 0. If it is so, if all 0, then is anagram, else not an anagram. Did you get that? What we are doing? Essentially, let's take a complex string. Let's take a more simple string or a complex string. A, B, G, E, E, G, E, D, G, E. Okay. So now, for, let's say for AE, we add, we subtract. For BD, we add, we subtract. For GG, we add, we subtract. This becomes 0. Then for EE, we add and we subtract. Now the values here all were not 0. Basically, since what essentially is an anagram has the same number of letters, right? The frequency of each element is same, right? So let's say A, B and B, A, each A should cancel the other A out, and each B should cancel the other B out. We are using that logic here. When we code it up, we will understand. So our is anagram is optimized to M, basically not M, to M, because we are also checking here whether each element is 0 or not, but it is still linear. This is logarithmic. This is still linear, this is logarithmic. This is always better. So now we solved our ON problem, we solved our M log n problem. Basically we have solved both our expensive problems. Now what is the logic? How do we achieve this How do we achieve this? Add only necessary elements. Add only necessary elements. So let's say we have this again, a b, b b, a, then we have a b, b, a, and we have c d, and we have d c. Chalo. Let's take this example. Okay. What we are to do, we are to pick one check behind, right? Pick one check behind. So essentially our first element should always be in the list. AB, AB. We always add the first element in the list because there is nothing behind. Okay. So now we start from here. We start from here. Are these two anagrams? Yes, they are. If they are anagrams, ignore, go ahead. Ignore, go ahead. We check this and this. Are these two anagrams? Yes. Ignore, go ahead. Are these two anagrams? No. Add this to the list. CD. Go ahead. Are these two anagrams? Yes. Ignore, go ahead, and return. Did you all understand what just happened? So, if this is an anagram of this and this is an anagram of this, it just means that both of these are anagrams of each other too, right? So, if this was there in the list and we check this, so we just ignore and go ahead. We just ignore and go ahead. Let's say this was not an anagram. If these two were not an anagram, then this would be this would be added into the list. This would be added into the list because these two were not an anagrams, and hence since this was added, this was his anagram, and this was not an anagram of this, this was not an anagram of this, and hence we add in the list because it is a unique element. So I hope you all understood the problem. We would quickly code this up and let's go. So basically what we need is a list of string answer is equal to new array list. Now we basically do ans.add words at 0. We basically add it into the answer list. Now for int I is equal to 1, because we're starting from the second element, I is equal to words.length, I is less than words.length, I plus plus. Now if not is anagram, what are we checking for? Words at I and words at I minus 1, I suppose, right? We're checking behind, right? If this is true, so basically if they are not anagrams of each other, we add it into the answer.add words at I, and that's it. After completing this, we return our answer. And now let's define the isAnagram function. Public boolean isAnagram string s string t integer array of count is equal to new int we need 26 characters, and if s.length is not equal to t.length, sorry for the disturbance behind audio, there's some construction going on, we just return false. Let's just declare this afterwards. Why to declare unnecessary memory if it is going to result false? So we did that. Now int I is equal to 0, I is less than s.length, I plus plus. Now count at s dot char at I minus a. What did we do here? Plus 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 and count at t dot char at I minus a minus minus. What are we doing here? We are converting it into an ASCII value. ASCII value of a is 26. ASCII value of a is 26. So basically, if my character was also a, so it would, if my character was also a, so a minus a, basically it would result in 26 minus 26 result in 0. So basically character a, which we assume to be 0, it would append here at 0. If this is the same, it would decrement from 0, right? So basically this is just ASCII. This we do it for all elements, and then for int c in count, if c not equal to 0, return false, else return true. I hope this works. And cannot find symbol s. What? Why? Just a second. Oh, I instantly realized what the issue was. This is not an array, this is a string. So compilation error s dot length. Where again? Here. Okay. My test cases should now run, and I submit. And I hope you all understood this problem. There you go. Our answer beats 99.78%. And yes, thank you so much for watching. I hope you have a great day.